Today we're just going to talk briefly about atomic spectra and the quantum hypothesis, which says that light can only be absorbed or emitted at certain specific amounts of energy. So in our last lesson you learned that light can behave like waves, and we did an overview of the electromagnetic spectrum. Today we're going to talk about how light can behave like a wave but also like a particle. And a particle of light is called a photon. And photons can interact with atoms or molecules to change their properties and change the energy levels that the electrons are sitting in. So in order to understand this, we first need to do just a little bit of a review of the model of the atom that we talked about in the last chapter. So one of the models that we mentioned was the Bohr model. And while this isn't the current view of the atom, it is the most useful one to explain transitions of electrons to different energy levels. So if this model represents the hydrogen atom, then we have one proton here in the middle, and then the electron, because hydrogen just has one electron and one proton, will be sitting out here in the first energy level. That is the level that is closest to the nucleus. It's the one that is the lowest energy for the electron because that negative charge is going to be attracted to the positively charged nucleus. If we were to hit this hydrogen atom with some photons that had enough energy, it could move to a level out a little bit further, or even all the way out here if it wanted to. And hydrogen has more energy levels than this, but these are the ones that are shown for our demonstration here. This process is called absorption. The electrons are absorbing light, or absorbing energy from the light that's hitting them. If they were to go back down, so let's use a different color for that. If an electron were to go from 3 back down to 1, for example, that process is called emission. And in order for the electron to move back down to lower energy, it has to do something with that extra energy that it has. And that extra energy is released in the form of light. And that light being let off is called emission. And it turns out that each atom has a very specific emission spectrum based on the energy levels and their the energy between each of those levels, and also how many electrons a given atom has. So hydrogen has a pretty simple emission spectrum because it only has one electron, but as you go up or further up in the periodic table and you add more electrons, the spectra get more and more complicated. So I'm going to just show you a couple of spectra here. We have lithium, cadmium, and strontium, and each of those has a very specific set of lines that you see when you hit those elements with photons of light. And if we were to mix some of these elements together, their emission spectrum would stay intact because it's very specific for that element. And so you can look at a spectrum of a mixture of elements and figure out which elements are present based on which lines are there. So for example, here we see a line here in the mixture, and that would correspond to this line here in strontium. Right? We don't see, for example, any lines in this region down here, so we know that cadmium can't be in that mixture. Okay? There are additional lines that aren't in strontium though, so something has to account for this line, for example, right? Because that line is not present in strontium, it's not present in cadmium, but it is present in lithium. Okay, so from the 3 individual spectra of lithium, cadmium, and strontium, we can look at a mixture spectrum and tell that it is a mixture of strontium and lithium. And every element has and every compound has a unique atomic emission spectrum, and we're going to take a look at some of those in the lab later in class this week. So let's take a look at more closely what each of these components are that are contributing to the spectrum. So energy levels is the name of the place where the electron can be energetically. So the lowest energy that can have is always n equals 1, and that n is the principal quantum number. So n equals 1 would be the first level, n equals 2 the second, n equals 3 the third, n equals 4, and so on. And as n, or the principal quantum number, goes up, the number or the amount of energy that the electron has also goes up. All right, and I already mentioned that when the electron absorbs light, it moves from a low energy to a high energy level. And if it emits light, that's when it's going from a high level back down to a low level. And that's what's shown in this diagram here. All of these are emissions. They're arrows pointing from a higher n back down to 1. An emission doesn't have to be back down to 1 necessarily, just going from a higher number down to a lower number. And what we see in terms of the spectrum is sort of the opposite for absorption and emission. The spectra I showed you on the previous slide were all emission, so you get lines of very specific energies or different colors if it's visible light. Whereas if it's absorption, then you would see only the places where the light was not getting through. Those would be dark. And so an absorption spectrum would look the opposite. It would look like this. So I think that about wraps up our discussion of energy levels and absorption and emission. And get excited because we're going to do a little bit of this in the lab this coming week.